Hey guys, so today we're going to be working on building and working with inverses of functions, and there's some conceptual things that are really like a big deal in terms of what is an inverse and how do we know it's an inverse. So traditionally we write, a function f of x, let's say it's 2x plus 3. Okay? If we think about what's happening in this function, the first thing that we're going to do, if I gave you a number for x, the first thing you would do is you'd multiply that x by 2. So we're going to multiply by 2, and then whatever that number is that we've gotten by doubling, we're going to add 3. That's the sequence of math that we're being asked to do. Well, the inverse function is always a function that will undo those layers. But it's really important that we talk about the way we undo those layers. So we use this the negative 1 exponent to represent the concept of an inverse. So when we have the same name, right, it's still f, it's the function f, but it uses a negative 1 exponent, we call it f inverse, or the inverse of function f. And so now we want to talk about what would this equation look like. In the homework video, we talk about, trade x and y places and solve for y, and that will give you your new equation. But I want to talk about it more conceptually for just a minute. We know that there's a multiplication by 2, so there's a multiply by 2, and we add 3. Okay, so, those are our two steps. We've got to multiply by 2 and we've got to add 3. So let's just pick a number. If I take the number 7, for instance, okay, if I multiply by 2, it becomes 14, and if I add 3, it becomes 17. Now the question is, can I undo those two steps? And the answer is yes, but it matters what order I do them in. Because if I just divide this by 2, right, the opposite of multiply by 2 is divide by 2. Well, that gives me 8.5. And I have add 3, well, the opposite of that is minus 3. That would give me 5.5. Is that the same thing as what I started with? The answer is no. So I need to make sure that I'm doing the opposite operations, division by 2 and subtraction of 3, but I have to do them in the correct order. And we want to do them in the opposite order that they're used in the original problem. It's like using the SADMAP approach. We talk about this all the time when I'm solving a problem. Okay? Start with your addition subtraction, then multiplication, division, exponents, and parentheses. We're doing this backwards of PEMDAS. That gives us structure to how these functions are really being built. And so the first thing I want to look for is any addition subtraction. So I take my x, whatever the number is I want to work with, the first thing I have to do is get rid of the add by 3. So I'm going to minus 3. Now I need to make sure that that happens before anything else. So I'm going to put that in parentheses. Then the next thing would be to get rid of the multiplication of 2. That would leave me with division by 2. This is an example of one way to write the inverse function. Think about it this way. If you put 17 in here, 17 minus 3 is 14. Excuse me. And 14 divided by 2 is 7. Back to that the original value I started with. So this function really does undo the original function. This could also be written as 1/2 x minus 3/2, and it would disguise the function matching the fact that it's the inverse function of the original. So this is the idea of what an inverse function does. It undoes or evaluates a value back to its original. And this is important for a lot of things. If I'm going to do an encryption code or something where I try to create a secret code or secret message, maybe your data online needs to be encrypted to keep it safe, well, I have to be able to unencrypt that or bring that back to regular numbers, and inverse functions are going to be how we do that. One other thing that's really kind of a neat deal that I think is worth talking about. Functions are really neat when you graph them. Unfortunately, we don't do a ton of this in class, but let's say that I graphed the parabola, well, not the parabola, let's say I graphed a cubic function kind of like this, a negative cubic function. If I wanted to graph its inverse, something we need to recognize is that the x and the y are being traded places. What that means is that the graph gets reflected along the line y equals x, where they're equal to each other. So if I were to try and graph this, and I'm going to do a terrible job, got to think about how this would look. I'm thinking, I'm going to screw that up. Oops, yeah, see, I missed. Something like that. You can imagine if it was reflected on that line or over that line, we would end up back on top of ourselves, which is really cool. All right, one last little thing to kind of talk about. So graphing is kind of cool because it's a reflection. I think that's worth looking at. But just to kind of finish up the conceptual piece of this homework is one last thing. We did these compositions where we put a function inside of another function. And the idea here is that if, we did an example with 7, where if I put 7 into the first equation, get a number, it gives me 17. I take that number and plug it into the other equation, it's going to spit out the original number, that it undoes itself. Well, we want to be clear that it works every time, not just sometimes. To do that, we actually need to put a function inside of its inverse with an x. Okay, so this is that composition where we don't have a number. And we would need to prove that it works both ways, okay? If you've ever seen the movie or the TV show Psych, it works both ways, heard it both ways. And so what we're going to do is we're going to show that when we put one function inside each other, that they wipe each other out. And so if we look at this, it would be 2 times something plus 3. But the something is going to be my other equation, which is x minus 3 all over 2. Well, when we cancel this stuff out, we got to do it carefully and by steps. This is really a 2 over 1, and a multiplication and a division by 2 to that whole group would wipe each other out, leaving me with x minus 3 plus 3, and a minus 3 plus 3 would cancel, leaving me with x. What that means is whatever number I put here in this x position, it will be the same number here. If you put 7 into this, you're getting 7 back. If you put 1,000 into this, you're getting 1,000 back. So this does essentially build a function that does nothing at all. It returns the same value you started with. But this is how we can validate that our system works. If you think you have the encryption built right, but you're not certain, you could end up losing and destroying a lot of data. You need to make sure that it is going to that the second function will just clear it. It doesn't work one time or 100 times, it works every time. And we can show that working both ways, that whichever one we call the original, it doesn't matter. So here we'd start with something minus 3 all over 2. But we'd put the other equation in, 2x plus 3, without any distribution to do, a plus 3 and a minus 3, they're going to cancel, leave me with 2x over 2, and those cancel, leave me with just x. So we can see that in either case, one function really does eliminate the other. That means we have something that's fixable. It's when we put something into that first equation, we know we can get our original numbers, our original information back. Logically, it's all about sequencing and steps and why does what cancel what. Good luck, guys. Watch the homework video for a little bit more help if you have some questions on your homework, but we'll see you in class.